All right, thanks a lot. Excited to be here. So yeah, I'm going to talk about MLflow, an open source project that we started about a year and a half ago. This is not about scaling up the machine learning algorithms themselves, but about scaling up machine learning development. How do you build production applications with a team of people and keep them running and build more and more applications? So I think everyone who's tried to use machine learning for real applications knows that it's very complex. It's quite a bit more complicated than traditional software development. So I'll explain some of the issues that happen with them and then how we're tackling these in the MLflow project. And I'll focus especially on some new things that we added to MLflow in the past 6 months or so. So why is ML development harder? So this is a slide I like to use to compare them. I just compare a few dimensions of each one. So let's start with the goals. So the goal in most traditional software is just kind of functional correctness. You have to meet some specification, and it's a Boolean goal. Either you meet the specification or you don't, right? Like when the user presses this button, you have to create a file or whatever it is. In contrast, in machine learning, the goal is to optimize some metric, usually about the real world, like the accuracy of your model. And you need to constantly experiment to make it better. Maybe every improvement of 0.1% and that helps you. And also the real world is changing, so it might just get worse over time, unlike the functional correctness, where once you've got it, it's going to stay working forever. So that's the first issue, is you have to think about metrics and track these metrics and think about data. The second one is what affects the quality. So in traditional software, whether or not your software works only really depends on the code. So you can just review the code, test it, look at it, and if it's good, then your application's going to work. But in machine learning, the quality depends heavily on the input data, of course, because you're trying to learn and generalize from data, and on the training method and tuning parameters and so on. So there are more variables you need to look at and measure to see how you're doing. And finally, thinking about just the kinds of software you need to stitch together, usually in traditional software, you pick one set of tools. Like you pick one database, one front-end web framework, one back-end system, whatever. You pick your favorite and you build it. And in machine learning, because you are trying to experiment all the time and there are new algorithms coming out and so on, you actually want to be in a position to use the best from any tool. If you're using TensorFlow and a new model comes out with PyTorch or with JAX, and that's better, then you want to quickly be able to switch to that. So that increases that operational complexity. And then, of course, this has to keep working later after you build the application in production, so you have to feed it with data. And here you run into maybe a different problem, which is that different people are responsible for the different parts of the life cycle. And as you pass the application between them, it needs to keep working. So this is a pretty important problem for anyone doing this. And so all the organizations that really use machine learning in products at scale have developed a solution, which is called machine learning platforms. So some of the best known ones are the ones at the large web companies, ones like FB Learner, Michelangelo, and TFX. And these platforms are used internally at these companies to build and deploy hundreds of applications. And they really, what they do is they package up and standardize the whole life cycle of the application. So data preparation, training, deployment, monitoring. So basically, if you work with the APIs of this platform, you get all these capabilities. And so these teams can build not just one ML application, but like 10, 20 models that go into just one user-facing application, like let's say Uber Eats. So these are super successful and they work great, but there are also some disadvantages with how people are doing this today. So first of all, in a lot of cases, the platform is very custom to each company, and the platform developers have to add support for new libraries or new frameworks. Does your ML platform support PyTorch yet? Does it support JAX, for example? This kind of stuff. And also, there's no sharing of work across companies because everyone's built it for their own internal tools that they have. So at Databricks, we saw this problem. We saw a lot of users, whether they're tech companies or just kind of traditional enterprise companies building custom ML platforms. And we asked, can we just provide these benefits, but in an open manner, so people can collaborate on a lot of these tools? And so that's what we did starting in 2018 with MLflow. So we built this open source machine learning platform. It's got a bunch of components. You can, of course, combine it with other stuff as well. And it is actually designed to run over existing cloud resources and cluster managers and so on. And the whole goal was to see if we can make components that work with any ML library and workflow you already have. So we have this, what we call open interface design philosophy, where everything's just REST APIs and text files, like very simple data formats, so that you can connect it to whatever custom stuff you have. So it's got these 4 components. It's got experiment tracking, project packaging for runs and workflows, model packaging, and then a new component, model registry, that we launched last year. And you can use them individually, or you can, of course, combine them, and they work well together. So I want to give a little bit of overview of these, and then talk especially about what's new in the past 6 months or so. And when we started this, we didn't really know whether it would work out. Is it possible to make something that that you can actually share across companies? But we've been very excited about the response of the community around it. So we've got a lot of people contributing to it, almost 200 contributors from over 50 different companies. And our team at Databricks, the team that I work with, is just about 10 engineers on this. So most of the contributors are obviously from outside. And we've also got these integrations with a ton of both open source and commercial tools. So things like RStudio, Azure Machine Learning, Cell.io, Splice Machine, Faculty AI, and many others. And it's up to about 1.4 million downloads a month on PyPy. And I can also tell you, just for customers on the Databricks cloud, MLflow has been used to track tens of millions of experiments and to build tens of millions of models. So quite a bit of work at large scale. And these are some of the companies using it. So to give you a sense of what it does, I'll cover the existing components and then a little bit of what's new. So first of all, the core components. The first thing that everyone most likely starts with is experiment tracking, because this is doing the actual development process. And so this is there are actually a bunch of experiment tracking tools out there, but the idea here is this is sort of a structured way to log information as you're running machine learning experiments and to query them after. So what we've got is we've got a simple API. You can use it in Python or Java or R, and there's also a REST API, so people are connecting to it from other languages as well. And wherever you run your code, you just instrument it with this API. You can log various things, and then there's a tracking server that's shared with your team that can show you all your experiments and let you compare them. So this is what that looks like. So these are some runs for an experiment. On each one, you see all these things that you logged. You can log things like files or graphs. And then it's sort of it's a collaborative tool, so you can take notes on it. It will link to, for example, the Git revision of the code that you ran. It'll collect a bunch of information about your environment and show you how this thing happened. So that's experiment tracking. And this ties in well with the other components. So second component is reproducible runs. So this is a way to actually declare the dependencies of your code and package it up as a Docker container or as a Conda environment and have someone else execute it or incorporate it into a workflow. And then the final one is packaging models. So if you want to deploy your model in production, you can likewise package it up into something like a Docker container. And we provide interfaces, so you can take the same model and run it as a server, or use a large-scale batch job with Spark, or deploy it to cloud services like SageMaker, or to debugging tools and so on. So these are the basic components, and they all tie together. Now, in the past 6 months, there's been a lot of new work. So there's been, to make this experiment tracking and model management even easier, we've got this feature called auto-logging that I'll explain. Which also starts to get into data versioning. To let you search and share models, we've got the model registry, which is sort of like a GitHub-like interface for models where you can review them with a team and promote them to different stages. And then we've also got new APIs like easier search API, lots of scalability improvements, and also a ton of integrations contributed by the community with different ML and runtime systems. So I'm just going to focus on a couple of these in this talk. So I'll talk about the auto-logging and the model registry, which are some of the bigger user visible changes. So let's start about auto-logging. So as I said at the beginning, we want MLflow to work with any machine learning library you have. Actually, a lot of our users use them with custom libraries that are closed source. They're just inside their company. So the initial, the basic API is you do your machine learning stuff. Here I'm just showing Keras as a very simple example. And then you write some code around it that will record this experiment using MLflow. So you can say, OK, I'm starting an experiment run. So then we'll automatically track whether it succeeds or throws an exception or whatever. And then you can log parameters. You can log metrics. You can also log a model. We have APIs for some common models, or you can just say, oh, it's a file, and I'll just save it as a file. So it's straightforward, but it's a bunch of work to type and declare all this stuff. So with auto-logging, basically, in a lot of common frameworks, you can now just call auto-log, and we wrap the fit function for the model or other relevant functions in, like evaluate in this case. And we just automatically record all the metrics that are in there. So here, if you've already configured Keras with meaningful kind of metric names, or you're using TensorBoard or something, we're just going to take that information and log it. So it's very easy to use and available for Keras and TensorFlow right now. And we're extending this quite a bit and creating a lot of other interesting integrations. So for example, one big piece of feedback we always got from users was we want to do data versioning as well. So we created an auto-logging interface for Apache Spark and for Delta Lake, which is an open source versioned table storage format that we developed at Databricks. And this will automatically log which data sources you read, like which tables you read from Spark into an MLflow experiment. And if you're using Delta Lake does copy and write updates, so it's very cheap to maintain historical snapshots of the data. So it'll also log that, so you can reproduce exactly the version of the data that was used during training. So that's for logging data stuff. If you're working in a more kind of full-fledged development environment, you can log interesting stuff there. So for example, on Databricks, if you're working in a notebook, we automatically take a snapshot of your notebook each time you call MLflow, and then we let you see exactly the code that was in there and other information about it. There's also work to do that for Jupyter. And of course, there are other frameworks. So PyTorch is one that's in development right now. So we're really excited about this. Basically, we say whether you're doing data science, machine learning, you should just have this almost like a flight recorder of what you did, so you can quickly go back and redo the things you need. So that's auto-logging. And then the second one I wanted to talk about is model registry. Actually, when we started MLflow, we did a user survey and asked what component people want next. And this was the one that everyone wanted. This was the top one. So we built that one. And so this is for the problem of model management. So if you've just done like machine learning in a course or something, and you haven't had to work with a team, maybe it doesn't seem hard to manage models. A model is just a file. you can store it and it's fine. But over time, you start developing many different versions of the model. You need a way to remember which one you built, and it gets it definitely gets a little bit hairy to deal with. And then of course, if you're working in a team or in a company that maybe has like compliance restrictions or things like that, it gets even worse. So for example, where do you find the best version of a model? How do you know how it was trained? Are there docs about the model anywhere? How do I find them? And also, how do I actually review this, sort of like code review or CI/CD? So that's the model management problem. So the model registry is basically a database of version models with provenance. We know which experiment run it came from and all the metrics and parameters used for that, comments and tags. And it's also got a bunch of APIs to easily access a given version. So for example, if you're the application engineer writing a downstream app, you can just say, I want to load the latest production version of the model called recommendation or whatever. And then you just pull that in, kind of like loading a specific branch on GitHub. So very easy for automated system or downstream users to use as well. And you can connect to it. We see people connecting to it from CI/CD tools and so on to manage their models. So here's what it looks like. So as you go in, first of all, there's a list of models, and you can see each model has a bunch of versions, and it's got these stages. It's got staging and production, and you can promote different versions to live in these stages. So the first model has, version 5 is in staging, but only version 4 is in production, because we're not done testing version 5 yet. So that's the list of models. Then when you click on each model, you can have a description of it, what it's supposed to be. You can have some metadata, and you can see all these versions, and you can manage which stages they're in. And then finally, when you click on a version, you can describe just that specific version, and it's got a link that you can see in there. It's got a link to the experiment run that built it if you're using MLflow tracking, so you can see exactly the code and data that went into it. And it's also got this feature, a little bit like pull requests, transition requests, where you can say, oh, it's in staging, but I want it to move to production, and then someone else, the model owner, can review that. Or you can use the API to connect something like Travis or Jenkins or whatever to run an automated test on the model. So very simple, but it lets you keep track of these models in an organization and use kind of a familiar workflow to work with them. And it works with any type of model that you can save as a file, so not just for one machine learning framework. So this is out now in beta form. It was released in MLflow 1.4, which came out in around October last year. And we would love to get more feedback on it. We've gotten a lot of interesting feedback already, so we're working to improve this. But we're excited about this for automating machine learning with whatever custom workflows you want around it. So given these tools, how do people use MLflow? So we've noticed that once you have this kind of automation for machine learning, teams can become quite a bit more productive and can also start doing machine learning at really large scale. So I wanted to talk about a couple of interesting use cases we've seen through Databricks that we didn't think would come out at the beginning. We thought there would be like individual data scientists making maybe one model per day or whatever and comparing them. So one use case we've seen in a lot of industries is actually a massive number of independent models. Let's say you want to train a separate model for each facility you have. Like maybe you're in a chemical company or something like that, or power company, and you want to predict some time series in each one. Or let's say you want to do it for each power meter from a customer household. Or let's say you want to do it for each user. There are some companies we work with that have customer data. So for example, Salesforce has data about everyone who uses it to manage sales, but they don't want information to leak between customers in ML models. They don't want to recommend the sales lead to someone because their competitor is talking to that person. That would be disastrous for if you've got these separate customers with separate data. So these teams actually want to manage a large number of independent models and make sure there's no leakage across them, just to have some sanity so like something bad doesn't mess them up. And the solution is to run large jobs, maybe using something like Spark, and then some AutoML library that updates each model. And then they just look at aggregate statistics about them. They say out of these like 1 million models, which ones are doing well, which ones are doing worse, and they change stuff about them. So very interesting kind of hands-free approach to ML that's been quite successful in these use cases. It's easy to control, and it has nice properties about privacy and so on. Just one example of this that talked about this publicly is QB. QB it's a startup company in Europe, but it works with some of the largest power companies and government organizations there. And so they look at over 400,000 homes across Europe, and they look at how those homes are consuming power, and then they send those customers these reports where they say, you're doing worse than your neighbors, and I think actually if you did your laundry at night instead of during the day, you would save on your energy bill and stuff like that. So this is an example where they have that approach. They have millions of models trained on these terabytes of time series data per day. And you can find talk from them at Spark AI Summit. You can find the video online. And then the other thing that we've seen a lot is even if your goal is just to make one model, you'll run a massive number of experiments. And so people want to do kind of big data analytics on the experiment results. If you run 1,000 or even 1 million like tuning runs and slice the data by different populations and so on, how do you take care of that? And so we offer these pandas and SQL interfaces to the MLflow tracking data that makes that easy. So we see a lot of users using that. And again, it's sort of a much more hands-free approach where you have a huge number of models. You're not going to babysit each one individually, but you can see something aggregate about them, or a huge number of populations you look at. So these are just some interesting use cases. You can find a bunch more in videos and meetup talks and stuff like that. So final thing I wanted to say is we're doing a lot of other open source work at Databricks, a lot of which ties to reproducible and scalable machine learning. So Delta Lake, I mentioned earlier, is this project we started in 2017. It actually used to be a proprietary feature of Databricks, but we thought it's so useful as a data format for managing data sets that we actually open sourced it last year. So this adds ACID transactions and versioning for data sets on HDFS or cloud object stores, and it's used at very large scale by our customers. Basically, Databricks is processing exabytes of data per day in Delta Lake format. So it's a more efficient and easier to manage version of something like Parquet or Hive, and it's good for reproducible machine learning, of course, because of the versioning aspect. So that's one you can check out. In HyperOpt, we contributed a backend to scale out HyperOpt jobs over Spark. Before that, you had to use MongoDB, and it was kind of painful to configure. But this is very easy, kind of one-line change you can use. And then we have this library Koalas, which is a Pandas API over Spark data frame. So that's if you're familiar with Pandas, that's worth checking out as well. So these are just some of the other things we're doing. But to conclude on the machine learning side, we think that ML platforms are very important for productivity with machine learning and for allowing teams to move beyond building one model to managing tens or hundreds of models. And we took this open interface approach to it, and we've got a lot of interesting collaboration as a result of that, and we'd love to get more feedback on MLflow and hear what would make it better. You can try it out on mlflow.org, and it's also super easy to run locally without setting up a server. You can just pip install MLflow. So thanks, and yeah, happy to take some questions.
Thank you, Matei. We have time for one question. Looks like there's one over there.
Hi. We heard of MetaFlow, DataFlow, CubeFlow, MLflow.
Yeah.
They all seem to be solving the same problem. So how does MLflow perform better than the others?
Yeah, so I think MLflow is actually a more comprehensive platform because we don't, unlike things like MetaFlow and KubeFlow and so on, we're not worried about just the mechanics of how to schedule jobs and so on. We're assuming you have a job scheduler already. We're looking at how do you track experiments, how do you collaborate, how do you code review stuff. So I think we have, we're less focused on the mechanics of like, oh, I want a way to launch jobs on EC2 and see how to do that, and more on the collaboration aspect. Like once you have those pieces, what is a model anyway? Like what kind of metadata should be in there? How do I review it? How do I share it with someone, and so on? So the most widely used components in MLflow are the model management and the experiment tracking parts, actually. And I think we have a really good set of integrations there that is valuable. And you can use this with other systems if you want as well. Like people are using it with Kubernetes, people are using it with MetaFlow and so on, but we haven't seen as much work on creating this kind of GitHub-like environment for ML.
Let's thank him one more time and then break for lunch. Thank you.